Hello, everyone, and thank you for watching. Many parts of our connected online world were built without robust security, and we are seeing the impact of that every day, increasing fraud rates, especially in these days where online business got even more important. And what do I mean with robust security? Something like effective security under attack, not 100% security because it doesn't exist, but the ability of a system to resist at least the attacks at scale, meaning attacks that do not come with significant cost per target. So in today's world, an attacker that really tried to poke a hole in our system was eventually successful and able to attack many targets at the same time. And we are seeing such incidents every day. Let me give you two examples. Phishing attacks. A phishing attack doesn't rely on a software that contains bugs. It doesn't rely on an attacker to break the security of a platform, nor the security of an app and existing security measures, such as HTTPS, passwords, OTPs, knowledge-based authentication in general. They don't protect against them. Many email attacks we are recently seeing are without any malware in it. And 32% of all confirmed breaches involve phishing. The second example goes into the knowledge-based verification. Asking people for their mother's maiden name, their first pet's name, their place to live 5 years ago is not sufficient to verify who they are. And for essentially two reasons, right? The first is that information is publicly available in most cases, right, at latest after the Equifax breach in 2017. And second, again, phishing attacks. You could just ask the user to enter that information, and a man in the middle might send that information to the end server, right, to verify and then get a wrong impression. This applies to cloud services as well as IoT devices, where the main difference is that your IoT device's login feature is not maintained by a large data center staff and cannot run large software packages to detect some known malicious IP addresses or phishing sites. So what we have done in the past, to stay in our analogy, we have focused on adding Bandaids to make it harder to break our system. And yes, that improved the security a bit and even might convince some attackers to focus on another one system first, but it doesn't add robust security. Most people listening to this might already be aware that FIDO is one of those effective methods that makes security significantly more robust. And the security of this method mainly comes from the inherent possession factor that we have added, the authenticator. And that's the reason why I want to emphasize that again. The authenticator holds the secret parts of the passwordless credentials, and we have authenticators in many devices already, and we call those authenticators platform authenticators. We have those in Android phones, in iOS smartphones, and tablets, Windows, macOS laptops, and desktops, and they typically support some biometric modality and some kind of PIN, some knowledge factor, but that knowledge factor is different because it is a knowledge factor which is only relevant in conjunction with the possession factor. And so in general, we can have support for more than 4 billion devices today. And applying and deploying that technology today brings quantifiable benefits. We increase sign-up conversion rates, we paired that with reduction in sign-up times, at the same time could increase the sign-in success rate, paired with reduction of sign-in time, reduction in account recovery, right, and all customers report reduction in fraud at the same time. There are numbers you can look up on the internet, and those numbers are from real deployments these days. And this is great that so many people have deployed that because it improves the security overall. And it shows that deploying this technology is already practical today. But nevertheless, that doesn't mean we cannot further improve it. And so we are working on that. The use of a possession factor is key for convenience and security, but it has an impact on the user journey. In practice, the ability to convince users to register authenticators and to detect whether a passwordless credential can already be used on or through the current device is a key capability for a successful FIDO deployment. Not surprisingly, the focus for further deployment is to make it easier for you to use existing passwordless credentials on any and through any device. Some concrete examples. Security keys have an interesting characteristic. In addition to their security, their life cycle is independent from the life cycle of your smartphone, tablet, or laptop. So you can securely bootstrap the platform authenticators on these devices when you replace the device. Enterprises give security keys to their employees, but most consumers don't have those, nor do they want to carry them. On the other hand, 2.8 billion credit cards are in use in the world, and plus the debit cards. So people already have and carry some kind of token. So wouldn't it be great if you could use your banking card to authorize payments on your smartphone as well, elevating the security of a card not present transaction to a card present level? That allows the user to securely bootstrap new devices using an internet-enabled banking card. That doesn't require new FIDO standards, but just a different class of devices to leverage existing ones. This could be one puzzle piece to get the security keys into the hands of consumers. Another example, and that's the ability to connect existing platform authenticators, similar to what you can do with security keys, to another device. Security keys can be connected to any device today, but there is no practical and standardized method to connect a FIDO platform authenticator to any other device. So today, many companies use out-of-band technologies like push notifications, QR code scans for that, but that comes with security impact, right? It's not phishing protecting. But we are also looking into a way to directly connect your platform authenticator to other devices as well. For example, to directly use the credentials on a smartphone or smartwatch for authenticating a session on your laptop. A third example, 3% of smartphones are lost or stolen in the US per year, and phones are being replaced with a new one after approximately 2 years. Wouldn't it be great to automatically migrate your passwordless credentials from your old phone to your new one, or from your phone to your tablet or to your laptop? The exact protocol to migrate the credentials might be up to the authenticator vendor to implement. And there will be likely very different approaches there with very different security characteristics. Some approaches could work directly, others might work via the cloud. Some FIDO members are already working on such concepts to synchronize credentials of a platform authenticator from one device to another. Many relying parties see a difference in the security characteristic of such a synchronizable credential compared to the security characteristics of a traditional passwordless credential. So working groups are working on ways to distinguish them. If you have an opinion on that, please share that. We need to get that right. This feature will make the use of passwordless credentials easier for users. In addition to these ways to improve the use of FIDO, we have also started to look into more broader use cases. So we have started to add robust security to session authentication for cloud services in the FIDO lines in the beginning, but we have recently expanded the scope to add robust security to other use cases as well. For example, payment authentication, or passwordless user-to-device authentication, or passwordless zero-touch IoT device onboarding, and remote identity validation to reduce the reliance on legacy knowledge-based verification, the KBV. All these developments help us to make the online world more secure. And please help to make security of our virtual world more robust. Your deployments are important and valuable, so is your feedback on the lessons learned. Thank you for your support.